right, this is Lewis Structures 6.02 Part 2. So we are doing Part 2 of 602. And we just left off with the fifth rule that carbon, nitrogen, and oxygen can form multiple bonds. They can share two pairs of electrons or three pairs of electrons. So we're going to go with example 3. Example number 3. What if we wanted to look at a covalent bond between two sulfur atoms and one carbon? What's that going to look like? Well, if you remember, rule number 3 is we have to do a skeleton structure, and the least electronegative element is central. So when I look at that, remember electronegativity increases as I go up the table and over. So if I look at carbon and I look at sulfur, yes, carbon is above, but sulfur's 2 over this direction. So sulfur actually has a higher electronegativity than carbon. Another good rule of thumb is usually if you have carbon, carbon tends to be central. So I am going to put my carbon in the middle, and I'm going to put my sulfur on either side. We're going to start like that. Rule number 4 is that electrons in the structure can't exceed the maximum. So I need to know what my maximum is. I've got one carbon and I've got salt. Let's see, 1 and 2. Carbon has 4 valence electrons and sulfur has 6. So this is going to be 12 and that's going to be 4. So I have a total allowed electrons of 16. So here we go. I go 2, 4, 6, 8, 12, or 2, 4, 6, 8, 10, 12, 14, 16. Okay, so I'm good on rule number 4 that I have 16 electrons, but I have, now I have to check for rule number 1. So rule number 1 is that every structure has to have an octet. And if I look at sulfur, I'm okay here. I've got 2, 4, 6, 8. And over here, I've got 2, 4, 6, 8. But look at my carbon in the middle. Uh-oh, I've got a problem. This does not meet rule number 1. It only has 4 electrons. Well, this is where rule number 5 comes in, where carbon, nitrogen, and oxygen can form multiple bonds. And so what carbon's going to do, think of that central atom as kind of being an electron cowboy. It's going to throw up a lasso and it's going to pull more electrons down to share more electrons. So now we've got carbon and it's going to have 2 pairs of electrons between it. And then we've got sulfur. And over here I've got sulfur. Okay, so do I still have 16 electrons? 2, 4, 6, 8, yes. 10, 12, 14, 16, sorry, yes. Sulfur has an octet. This sulfur has an octet, 2, 4, 6, 8, but carbon only has 2, 4, 6. So carbon is still not satisfied. So it's got to lasso up another pair. It's going to pull this pair of electrons down. Now I have carbon has got 2 pairs on each side. I've got my sulfur, and we usually like to put the electrons kind of far apart. So do I have 16 electrons? 2, 4, 6, 8, 10, 12, 14, 16. Yes. Does this have 8 electrons? 2, 4, 6, 8. Yes. How about this guy? 2, 4, 6, 8. Yes. And carbon now has 2, 4, 6, 8. So my final structure, when I replace my bonding electrons with dashes, looks like this. This satisfies both rule number 1 and rule number 4, but that's why it emphasizes why it's so important for you to always check and see that you've satisfied both the laws. You have to have total electron count and you have to have an octet. So this is the final structure for sulfur and carbon. Again, to review what we looked at in this example, we have 2, 4, and now I count these dashes as 2. So I have 2, 4, 6, 8, 10, 12, 14, 16. And I have to check for octet. Sulfur has 2, 4, 6, 8. Sulfur has 2, 4, 6, 8. Carbon has 2, 4, 6, 8. So this is a good Lewis structure. All right, I'm going to pause the video while I change the page. Okay, we have, so you have probably flipped to the next page in your packet, and we're looking at Lewis structures continued. So there's actually going to be 3 videos over this. The next one, so we're going to do example 4 here. And example 4 is a compound called cyanide, and yeah, it's the cyanide you're thinking of, where it's the poison. It actually stops the electron transport chain, and we can't make ATP. So cyanide is 1 carbon and 1 nitrogen, but we've got something special going on here. So look at this -1 charge. Sometimes we have situations where a covalent compound will pick up or drop electrons. And the result is the whole molecule has a charge. So the whole molecule acts like an ion. So we call this a polyatomic ion. Because it's not a monoatomic ion where we have like chloride that has a -1 charge or sodium that has a +1 charge. Here you've got a whole molecule. And let me just say that again. There's a whole molecule, and we either pick up or we drop electrons, and that's what's happened here. So before we do too much with this, let's look at what this Lewis structure looks like. So I have 2 atoms, so I don't really have to worry about my skeleton structure. I've got a cyanide and I've got a nitrogen. I'm sorry, I've got a carbon and I've got a nitrogen. Carbon has 4 valence electrons and nitrogen has 5. So that's a total of 9 valence electrons. But look at this guy. He has a -1 charge. So that means that in addition to my 9 valence electrons, I picked up an extra. So when I look at my total allowable electrons, I have 4 from carbon, I have 5 from nitrogen, and I have 1 extra. So my total valence electrons here are 10. So let's go ahead and apply those. And I'm going to go 2, 4, 6, 8, 10. Okay, so rule number 4 is satisfied where I have 10 valence electrons. But when I check for rule number 1, 2, 4, 6, 8, this guy has an octet, but carbon only has 4. So I'm going to have to bring 2 pairs of electrons down to share. This guy needs 4 more electrons. So let's see what happens. I've got my carbon, I've got my nitrogen, and what if we share? So we're actually sharing 3 pairs of electrons. Can we do that? Yeah, carbon and nitrogen can. So can oxygen. Okay, I need 10 electrons. Let's do a check. 2, 4, 6, 8, 10. That's good. Does carbon have an octet? 2, 4, 6, 8, 10. Does nitrogen have an octet? 2, 4, 6, 8. Yes. So when I draw this Lewis structure, I'm going to go like this, but because it's a polyatomic ion, I have to put the whole thing in brackets, and I have to put the charge outside the brackets. So that's something extra we have to add. All right, so you'll have an assignment. Each one of these videos has a different assignment that goes with it. So you'll be doing assignment today that has polyatomic ions in it. And then it has multiple bonds. So the next lesson and the last one for Lewis structures is something called a resonance structure. But that's all for part 2. Thanks for watching.